Here's an idea. Jumping 8 steps down and 6 steps up ends up on a different distance than jumping 8 steps up and 6 steps down. Welcome to the first episode on the Chinese story on temperament, or how the Chinese deconstructed the concept of making sounds into music through rationalizing the tones. Before the usual talks about different forms of music ancient China had, and usually that means what instruments, melodies, and how they work together, and what scales or agreed systems of tone arrangement they used, we need to discuss the building blocks that rationalize the makeup of these systems. A common discovery of sound, no matter which culture it is, was that it can be differentiated into higher or lower pitch, depending on the number of vibrations of the sounding material, or frequency. Of many different pitches, some sound harmonious or right with the others, because it is a partial matching overlap with each other. This discovery led to the human curiosity to discover more of these kinds of relationships involving more sounds, eventually leading to different sizes and ways of collecting, organizing, and curating them, and thus spewing forth the ideas and belief systems that spawn the cultures. This is the study of music. The Chinese used 3 specific types of instruments to help them test, measure, and record the results in the journey of this discovery. While they had the means to create many instruments using 8 categories of materials: silk strings, metal, stone, skin, wood, bamboo, gourd, and clay, only 3 of them are used for the purpose of measuring the intricate relationship of sounds. These 3 are the plucked string of the qin, the bamboo pitch pipe guan, and the hold variants xiao and di, and a metal-struck bell, the zhong. These 3 representative instruments each cover one category of the modern hornboss-style sax instrument classification system: the chordophone, the idiophone, and the aerophone. Unfortunately, no membranophones, drums are a fickle thing to tune, and no electrophones, for obvious reasons. Electricity wasn't a thing until the late 19th century. By altering the vibrations on the surfaces and lengths of these 3 types of instruments, the Chinese discovered the first relationships of sound are simple fractions of a given vibrating body, such as dividing a string in half, thirds, quarters, fifths, and so on. Furthermore, for each fraction where the denominator cannot be further divided, in other words, a prime number, a new unique pitch is then created. The earliest written account of such a curation of notes is from the Guanzi, written by Prime Minister Zhong of Qi, who lived from 720 to 645 BCE, on all things related to governance. He equates determining the 5 primary sounds to the same as that of distinguishing the 5 cardinal directions, north, east, south, west, and center, the 5 soils, waters, and 5 different grains. While this may sound crazy to our modern scientific knowledge, take a look at how he compared them in stanza 7 in chapter 58, Diyuan. The sound of zhi sounds like the cry of boars and pigs, alert and terrified. The sound of yu are such as horses in the field, and gong are like oxen grunting in a pen. The sound of Sheng is that of a stray sheep, and jue that of pheasants calling on top of a tree, sharp and shrill. In devising the 5 sounds, first take a sound, and then divide it by 3. Open up or multiply it by itself 4 times to reach the number of 9 nines, 81. This is the gong sound generated from Huangzhong and is the prime of the series. Now add a third itself onto that, we get 108. This is zhi. Now remove a third of that and we get Sheng at 72. Now we add a third back to itself, and this is yu. This is 96. And then remove a third of that, and that is jue, or 64. So why did Prime Minister Guan stop there? One argument, as presented by Professor Cui Xian from the Wuhan Music Conservatory, was that the 5 sounds particularly referred to the practical application and positioning on the chin, where the first 5 strings are positioned in this exact order, in standard tuning. The simpler, more direct explanation might be that if we divided 64 into thirds, then we stop getting integers. 21 and a third just doesn't sound so clean to present, and he was trying to argue for the natural justice of recognizing just 5 things in the real world, so he left it at that. But reality was, by then, the Chinese have actually long discovered and recognized the 12-tone system, where 5 of them, and sometimes more, are picked out and used at any given moment. So why 12? By splitting the lengths into 2 makes effectively the same tone but higher, so that by itself is not enough to create different notes to play with. So the next logical choice would be to split a given length of pipe or string into 3s. After some experimentation, the sages caught on that by doing this enough times, namely 11 times, they can come up with a series that can largely return to the same note that they started with. So, if we are to continue the method as described in the Guanzi, we would end up with 12 distinct tones with a significant distance between each other, with the last one returning to the original, but not quite. And we'll leave it at that for now. We'll get to it. But here comes the next problem. Provided if we started with a reasonably long pitch pipe in the beginning, and in the process of adding and removing a third to it, and only thirds, it'll get too short to be manageable. So while it's possible, always, to double the length of the existing pipe to lower the octave back to the original octave and give yourself more leeway, but it would no longer be a pure figure calculated by thirds, but halves and thirds. So, what do? Fast forward to just a few decades before the Qin state unified China, and then Yingzheng declared himself emperor. His minister, Lü Buwei, released the book to the public and challenged anyone to find a fault in its content. Like the Guanzi, it was a book that supposedly covered everything in terms of arranging knowledge, but specifically for the purpose of governing a nation. And topics on music and musical measurements consisted of 2 chapters in Lü Buwei's Annals. Here's what it said. In the past, Huangdi ordered musician or linglun to make or organize the tones. Musician Lun then took some bamboo from the Jie Valley Gorge, selecting those ones that are thick, equal, with a distinctively hollow middle. He then chops them between 2 sections, and which measured 3 9/10 of a cun. He defined this as the tone of Huangzhong, and after blowing its tone, it sounded like the sound hriak hriu. He then created 12 subsequent pipes, and takes them to the foothills of the Kunlun Mountains to compare them to the calls of the male and female phoenixes. The male phoenixes cried out in 6 different pitches, the lot, and the female ones another 6, the lu. They matched when they're compared to the Huangjong fundamental pipe, and said pipe could derive all those other sounds. Hence, it is said that the Huangjong fundamental, the gong, is the fundamental, the ben, of the Lutlu sounds. Huangdi then ordered Linglun and Rongjiang then to cast 12 bells in accordance to the discovery of the 5 sounds, as a demonstration to the virtues of the tones themselves. They were officially played in the month of mid-spring, or second month, or in the Western calendar, March, and on the day of Yimao, when the sun was at Kui Mansion, or in Western terms, the Pisces and Andromeda constellations. And he named that music that was played Xian Chi. And from another section, from the Almanac of Late Summer, Notes and Pitch Standards. The 12 tones are: Huangjong creates Linzhong, Linzhong creates Taicu, Taicu creates Nanlu, Nanlu creates Guxian, Guxian creates Yingzhong, Yingzhong creates Ruibin, Ruibin creates Dalu, Dalu creates Yize, Yize creates Jiazhong, Jiazhong creates Wuyi, and Wuyi creates Zhonglu. In the divisions of threes, by adding a third, we call this an upward derivation. And the divisions of threes, by removing a third, we call this downward derivation. Huangjong, Dalu, Taicu, Jiazhong, Guxian, Zhonglu, and Ruibin are upward derivations, while Linzhong, Yize, Nanlu, Wuyi, and Yingzhong are downward derivations. You'll probably notice by now that why are there not 6 lut and 6 lu in Lu Buwei system, but rather 7 lut and 5 lu? Well, it does not say so explicitly in the text, but pay attention to the second part. If all the lut are created with an upward derivation, and all the lu are then created downwards, you'll find that Da Lu, or C sharp, stands out from the crowd. Instead of a downward derivation from Ruibin or F sharp, which raises the pitch to the same thing but a higher octave, it consciously makes a turn back down 1, without a second step to double the length of the remaining pipe. This proved the Chinese mastery and recognition of not only the upward and downward motions along the cycle of fifths to generate a largely enclosed cycle of tones, but the relationship and manipulation between the two movements to create such a curation of tones. So, Da Lu is female, but it's now made by Lu Buwei to be a male, but that technically still belongs to female group. But god damn it, Lu Buwei! But in accordance to Da Lu supposedly being a Lu or Yin sound, a later historical document does record it that way and subsequently put it back on a higher octave. The first record to do that was Sima Qian's Shiji, or Grand Records of the Historian, in the 2nd century BCE, because Sima Qian didn't turn the other way around on Da Lu. Every other note after that went on a higher octave, but they are still in perfect 2-to-1 ratio with the other account in Lu Buwei and his book. So, in other words, both are technically the same, and that's fine. So this is the basis of 三分损一法, the thrice divide, subtract, and add method. The method described in both Guanzi and Lu's Annals. By having Huangjong going downwards towards Linzhong, followed by upwards towards Taicu, and so on. The down 8, up 6, down 8, up 6 process is known as Zheng Sheng, or right direction derivation. In Western music, by the way, they're more used to calling 8 semitones, counting the original, by the way, a perfect fifth, and 6 semitones, perfect fourths, because that's how many full steps that would be on a heptatonic scale. Now, if you were to flip the direction around but maintain the number of steps in each, so up 8, down 6, up 8, down 6, that would be the 逆声, or reverse direction derivation, because the down 6, or going up a fourth, involves reducing a given tone to 3/4, i.e. not a third a division. This move is considered invalid, and hence the process is considered taboo. It is important, as we'll get back to this process in later parts in history. People actually do use this process. 三分损益 basically creates 12 tones in the same manner as the Pythagorean temperament in its own cycle of fifths. So it's fine if we said that 三分损益 is basically Pythagorean temperament in Chinese, right? Nope. While it is often compared or even equivocated to what Western music calls the Pythagorean tuning method or temperament, Guanzhong's record preceded Pythagoras by over a century, and its method contains few fundamental differences. While both recognize the premise that a perfect version of a tone in its higher or lower form is in half or twice its length, while altering frequency lengths by thirds generates a cycle of 12 distinct equidistant tones. And sadly, these two systems will never agree with each other at the same time. The way how these two systems manipulate the thirds are different, and it matters. The Chinese system creates this oscillating sequence of tones, going up and down in pitch, because it adds and subtracts lengths in one given sequence, and that sequence can only go in one direction, forwards, or 正声. The pros of this system is that all the tones generated are wrapped up in one octave, and all the jumps are pure just fifths, representing the simplest fractions of the original frequency. The Pythagorean scale, or the Pythagorean cycle on the other hand, is a continual process of just shortening or just lengthening, creating a spiral of 8 lü, or fifths, going up or down in only that direction, which expands quickly into multiple octaves, and using a mix of tones generated from both going up, so cutting into 2/3, or going down, adding into 4/3, the 12 tones are discovered through a multitude of different ranges. It is argued that it is this fundamental difference in how the subsequent tones were discovered, the order of how they were discovered, led to the fundamental split between the East and West on the treatment of these 12 tones. The Western tradition went for heptatonism, that they had to search both sides of the spiral in order to fill their base octave, and 7 is the amount of natural tones that they find will fit the scale. Meanwhile, the Eastern penchant for pentatonism, that the first 5 notes form the most stable, self-contained, and largely equidistant system, originated from the stability of 三分损益法's first 5 integers, if you remember Guanzi's numbers. But no matter which path you take, the same problem persisted and presents itself. The cycle does not return to the original note. So how do you fix that? Before you even get to solving that problem, a more fundamental question needs to be asked. How big is that gap? And in what way can you fix a gap that big, or worse off, that small? Welcome to the world of 律学, or temperament studies. From here, we embark on a 2,000-year journey of discovery, creativity, and animosity between some of the greatest musical, mathematical, and political minds in history on solving this mission impossible. Or is it? I'm Uni Young, and this is the concise history of Chinese musical temperament. A big shout out and thank you to all new subscribers and Patreon supporters. If you're dying to hear what happens next, or you think my work is pretty decent but think I'm releasing these videos way too slowly, please pledge a couple of dollars my way. It really means a lot to me. And your monetary support means that my work is being supported by something more than just the number of views reported by YouTube. Do they mean robots, cats behind a keyboard, or some unfathomable superior being that shall not be named who's doing this? Your name and your face matters, so sign up your support today. Also, subscribe and hit the bell icon to make sure that as soon as the next episode comes around, you'll be the first to know it. Join us next time as we discover how Han Dynasty musicians and mathematicians, or around a century before Christ, discover and measure the comma, and propose the first solutions to the game of mathematical whack-a-mole. If the system is broken, just keep going. Until then, keep tuning your strings, folks.